In example 9, they want to know by approximately how much does the area of a circle change when the radius increases from 4 inches to 4.01 inches. So I guess I need to know what the area of a circle is. So from geometry, you may recall that the area as a function of r is equal to pi r squared. Now, I'm using function notation here because I'm going to take the derivative, and so I want to know what I'm taking the derivative with respect to. But in geometry, you just wrote a equals pi r squared. But let's go ahead and take this first derivative of our area function. So a prime of r is going to be, using the power rule, 2 times pi times r. Now, that may look familiar to you. That is the formula for the circumference, and it is curious that the circumference formula is the first derivative of the area formula. This is one of those really cool things that happens a lot as we continue to study derivatives. But we don't need the circumference for this problem. We do need the first derivative because it's a rate of change. And let's take a look back at our problem and see what we're trying to do. So they're telling us here that in this case our A value is going to be 4 inches, and the X value, or in this case R value of interest, is going to be 4.01 inches. Okay, so let's do a little bit of work here. Let's find out what A of 4 is. So A of 4 is going to be equal to pi times 4 squared. That's going to be 16 pi. And A prime of 4 is going to be 2 times pi times 4, and that's going to be 8 pi. So now the delta A as a function of r, you know what, let's just call that delta A. So delta A is going to be equal to A prime of 4 times r minus 4 plus A of 4. So do you recognize this as our slope line? This is, or I'm sorry, our tangent line. This is y equals f prime of A times x minus A plus f of A. So this is the very same formula that we've been using. We've just changed the variables that we're using to fit this problem. And so let's go ahead and substitute and find out what delta A is going to be equal to. So delta A will be A prime of 4, that was 8 pi, and we're going to be multiplying by r, which is 4.01, minus 4, plus A of 4. A of 4 was 16 pi. And we can simplify this. We get 8 pi times 0.01 plus 16 pi. And at this point, I need to get a numeric approximation. So let me say something about that. On the AP exam, you're going to need to provide at least 3 decimal places for your answer. And so that means that if I do any decimal calculations in my work, I'm going to carry at least 5 decimal places, because any function of a value of 5 decimal places, even square root, should be accurate to 3 decimal places. But what I have done is I have left my irrational numbers 8 pi and 16 pi as exact values right up until the last step, and I'm going to plug this into my calculator and round it to 3 decimal places. So let's take a look and see what we get. Let's open up our calculator, and so plugging this in, 8 pi times 0.01 plus 16 pi, we get 50.5168 for decimal places, so 50.517. But you know what? I'm just going to put 50.5 5 168, because if you give them more than 3 decimal places, that's fine. Also, it doesn't matter if you round or truncate. Truncate would just be to cut it off. The other thing that is so important for me on a problem like this is to make sure that I include the correct units. If I stop right now, having done all of my calculus correct, I'm going to immediately get -1 because I did not include the correct units. This is a change in area, and so since it is a change in area, I see that my radius was measured in inches, and so my area is therefore going to be inches squared. Okay, so 2 things to think about on the AP exam. One is decimal places. You need at least 3. And the other is units. By the way, even if you miss the complete problem, but you have the correct units and a numerical value in front, you'll get 1 point just for having the units. That works for you. Make sure you don't forget it, and don't let it work against you.